Hey guys, happy Thursday. Hope you guys had a good day yesterday. My voice is a little hoarse, so I'm going to talk a little bit quieter than normal. Let me go through with you if you missed class today on Thursday. What we did, we started with the do now, where I just was asking you to summarize the point of this activity that we did on Tuesday. If you have no idea what I'm talking about, then go back and do this activity, and then this will make more sense. We are building on ideas this week, Tuesday, Wednesday, Thursday, Friday. So make sure you start at the beginning if you're missing class. By the way, like this slide says, if you are missing class, you need to make up the work. We will take an assessment on Friday, and I want you to be ready. When you do make it to class, I'm going to ask you to keep your cameras on, and you're going to do it. Okay, so quick science of the day. We're going to talk about what the Earth is made of, look at some evidence of what the ocean floor looks like, and put some information together with some videos and questions. This is Dr. Karen Block, who's an American geochemist, who she looks at the chemistry of the Earth. She's born in Puerto Rico, and she got her PhD from the City University of New York. Excuse me, I'm going to put this comma here because it's bugging me that it's not there. She gets to travel a lot for her work. And she is big on trying to get more Latino students, Latinx students, into the earth sciences. If you want to see a little bit about her, go ahead and click on her scientist profile, and you get to watch a couple-minute video about her on PBS. This is a picture of everybody. I'm guessing this is in New York. I thought maybe it was in Costa Rica, but it looks like maybe not because there's so many. Everyone's got jackets on and stuff, so it looks like it's cold. Yeah. But hey, that's what you get to do if you get to study geology, the study of earth science. You get to go and do cool stuff and bang on rocks and look at rocks and stuff. Kind of cool. So we are learning about earth science, and I've shown you this every time this week. And so I just want to remind you that we are looking at the evidence for this idea of continental drift. And here's this idea. So the continental drift is a theory stating that the Earth's continents have been joined together, and since then, they have moved away from each other and are still moving today. So during this unit, you're going to analyze that evidence. And yesterday, or Tuesday, we looked at these two. We looked at the shape of the continents. We looked at the distribution of rocks and fossils. Today, we're going to look at something called seafloor spreading. We're going to look at what the ocean floor looks like, find some data on it, and that's another really strong piece of evidence for this idea that the continents are moving. We'll also watch a video about satellites, the things that go around the Earth and how they can help us measure movement of continents as well. So here's some background knowledge you may or may not know. The Earth has layers like an onion, like an ogre. The outermost layer we call the crust. You're going to need to know that. It can be 3 miles thick in some places. It can be 50 miles thick in some places. Below that, below you, 5 to 10 to 20, 30 miles, is mantle. It's like mostly melted rock. It's kind of solid. It's kind of liquid. It flows really slowly like a Play-Doh or something. Below that is a liquid outer core made of heavy metals. And then so much pressure on the inner core. Here's another image of that. So inner core, outer core, mantle, and the crust is just the very top layer. Which layer do you think you live on? It's the crust. Yeah, you live on the very outside. You actually live on the crust. So the crust is a thin shell of hard rock floating on the top of the mantle. We're going to need to know that. We have two different kinds. Oceanic, that's the crust underwater, the rocks that exist under the ocean. You have the continental crust. That's basically where the 7 continents are on top of, that's like land. And it's actually the crust, the layer of Earth is a little bit different. It's thicker, makes some sense, where there are the continents than in the ocean. Below that is the mantle, which is between the cool crust, where it's cooled off on the outside, and the really hot core below. It's about 1,800 miles thick. It's about 80% of the total Earth's volume because it's much thicker than most of it. And it's plastic. They call it plastic, not because it's like plastic, like your phone is plastic, but it is not really solid nor liquid. It kind of acts like in between. It's mostly solid, but it does slowly move. I read this somewhere that it moves about the speed of your fingernails, which is kind of nuts. Although that's not that slow. It's slow for you because you think like every day, but the Earth is 4.5 billion years old. And so it can, over that amount of time, the mantle can move a lot. I also like this question. Think about which parts of a peanut M&M are the crust and the mantle. Peanut M&M, the peanut's kind of like the core. The chocolate's kind of like the mantle. And the candy on the outside is like the crust. Yeah, I like that. Okay, we're looking at a map here today. This map represents the ocean floor. It was made from scientists studying the age of rocks on the ocean floor. And if you look, the red color over here shows really, really young rocks compared to blue, dark blue, purple, pink, which are showing much older rocks. And look at this map. Look how we have these long lines of red. Very new rock happening here. New rocks happening over here in the Pacific Ocean. New rocks down here, down here. And look at some of the blue, the purple, the pink along here in North Africa, over here on the east coast of the United States, over in the western Pacific Ocean by Japan and stuff. So have a lot of red, older rocks. It's interesting. So we now know the different colors represent the age of the rocks. You can think of it, it's better the age of the crust, which is essentially by studying the age of the rocks. Similar idea. Okay, so in breakout rooms, you can click on this link and it'll take you to this map right here. You can look at it and try to answer these questions. Where is the ocean floor the newest? Where's it the oldest? And maybe think about why are some areas new and some areas are much older, hundreds of millions of years older. Interesting question. And then I want you to click on this Google Maps. I want you to move around and so zoom all the way out so you can see the whole Earth and find this ridge. You have to zoom out where North and South America and Africa are on your screen and you're looking at the ocean there. I want to know, what does it look like? Now zoom in along this red line. What does it look like? Same thing for number 5. Here's Mexico, Central America, South America. If you want, go to Google Maps and type in Mexico and then zoom out. And you'll see a picture like this where you see Mexico, Central America, South America. I want you to zoom in down here near kind of, was it like Chiapas, Nicaragua, El Salvador, Guatemala through here. And what does the ocean floor look like there? The ocean looks different in different places. We can kind of get an idea of what's going on. So do that, and I'm going to keep, and then pause me, go and do that because it's super interesting to see that. I love Google Maps. Try not to get lost in doing some cool Google Maps lurking, and then come back and I'm going to keep going. What you might have just seen is evidence for this idea of seafloor spreading. You saw ridges and valleys, trenches. So we're going to talk about ridges and trenches in the ocean. What happens in the middle of the Atlantic Ocean and in many other places is a huge, where the mantle is rising up below the crust. And it's pushing the crust out. It's actually spreading the seafloor out. I like this image down here. You can easily see that. It's called seafloor spreading. You basically get this new conveyor belt. It's at this location that new rocks are made. Essentially magma, the mantle, the magma, the lava comes up. Magma and lava are the same thing. It's called magma when it's under the crust, and as soon as it comes out of the earth and at the top, it's called lava. Essentially the lava is coming out and cooling, and that new lava is the new crust, and everything gets spread apart a little bit while this is happening. So this is how seafloor gets spread. But now there's also the other side. So because it's like being pushed apart in places, the older, denser oceanic crust will sink beneath. You see this happening here where this pink arrow is running. This thing is sinking below. These are called subduction zones. These form trenches, or where the other ones, these seafloor spreading, forms this ridge. Here, these will form a trench. This is where Earth's crust is destroyed. So there are places on the Earth where new crust is being born, being created, and where an old crust is being destroyed, going back down and melted and put back into the center of the Earth. It's crazy to think about this happening. So this evidence, the fact of continental drift that we've seen, the continents fit, we see fossils all over. Now scientists are looking at seafloor spreading. They're understanding ridges happening and subduction zones happening. And this led geologists in the 1960s finally to realize that the Earth's crust is broken up into pieces. And we call those pieces tectonic plates. They float on top of the mantle and they move really slowly over time. This will be the first of many times that we talk about tectonic plates. So this week is just about, hey guys, tectonic plates exist. This is how we know. We looked at all this evidence. Next week, we're going to start looking at, okay, so tectonic plates are a thing. So what? And we're gonna get to see all the different the so what of tectonic plates moving. We're gonna link them to volcanoes and earthquakes and mountain ranges and valleys and lakes, and so many things are what? Islands. Sorry, my throat again. So there's a lot of what happening with tectonic plates. For your independent work, there's 2 videos. I want you to watch them both, and for each, answer just a couple of questions. It won't take you very long. Don't forget your homeschool connection is due tomorrow. Do it, please. That you have to go back to Monday's lesson. Go back to Monday's lesson on Google Classroom. It would be Unit 4, Lesson 01, L01, Earth Science, and that's where you'll find your homeschool connection if you haven't done it yet. Okay, 2 videos. This one you have to take the link to it. I think 2 questions for each video. Nope, 3 questions for this one. Oh, well. And that's it. Answer these questions and come Friday ready to do a little bit more practice and then the quiz on this. I'll see you guys later.